go. Good morning, everybody. This is the voice that I use for my recording voice. It's pretty exciting. I don't know if you guys have been around for it, but when you get a chance to hear me talk like an idiot, it's lots of fun. So what we're going to be doing today is the second problem. Negative 5x plus 2y equals 14, and y is equal to 3x plus 2. I will ask, when you look at this one, how do we know we're going to use substitution to solve the system of equations? Somebody should write it in the chat and say, well, this is how I know. Yep, y is on its own. Whenever you got a variable on its own, the general idea is that you are going to look at this and say, okay, well, what I'm going to do here is I'm going to substitute one thing in for the other. Holy cow. Whoo, did this freeze? What just happened here? Okay, that's me. Let's try this again. For some reason, everything froze up, and that's not what anybody needs. Let's see if I can make this work. Okay. Okay, now it moves. That was really strange for me, guys. I did not know what was happening. Okay, so if we got y on its own, we're going to do a substitution. I'm going to take this y, and I'm going to plug it in right there for where that y is. Can you guys see this okay, by the way? Okay, so if I'm going to do that, I got to rewrite that top equation, negative 5x plus 2, and then I'm going to use a set of parentheses here when I replace that y, equals 14. And then I'm going to take the expression that y is equal to, and I'm going to put it in here, replacing or substituting for the y. So now we got 3x plus 2 here. Now, I have not solved any of these problems. This might completely and totally suck, but we can at least go through and see what we're going to get. What's my next step? What do I do? Oh, somebody's got to write fast or else we're not going to get to it. Anybody? What do I got to do?
Minus 14.
That's weird.
Wait, no, 2. That's what I meant. Wait, no. Yeah. You distribute 2 to the 3x and the 2. I don't know what I said minus.
No, it's totally fine. We got into a place where it got glitchy for what was happening. So I was listening and it sounded like, and then I didn't have any idea what happened. And so now I know. I am going to distribute there. And when I distribute there, my new equation is going to be negative 5x plus 6x plus 4 is equal to 14. Now, I would ask questions of all of you guys, and I think that'd be fine, but I recognize that we are of a limited time and I want to get through everything. So combine like terms here. Negative 5x and 6x is going to give us x plus 4 equals 14. If I subtract 4 from both sides, I'm going to get that x is equal to 10. All right, we're one step away from the answer because we have our x. Now I got to solve for my y. Great thing about the y, hey, look, we have a whole equation set equal to that y. So if I take this and make sure that I replace that 3 with the 10 we just found, holy cow, I can hardly see that. Can you guys see that? The green? Green feels like a bad color to use. I won't use this color anymore, but I can show you what we're doing. 10 goes right in there. So we got negative 3 times 10 plus 2. That will become 30 plus 2, or 32 for our y. So if we have our x is 10 and our y is 32, that means that our final solution for this will be 10 comma 32. Y'all good? Give me a plus or a minus if you're all good. I see the thumbs up there. Solid. Got some pluses. I got an equal sign, which is close to the plus. I know it's directly below it. I've had the problems with that as well. Okay, so with that being said, I think we're good on solving with substitution. The next type of problem you're going to have, and we're going to kind of skip through some of the notes a little bit here too. They're going to look like this. And these are set up in such a way that we are looking at solving systems of equations by substitution. Not substitution. God. Okay, this is what we're going to do. Hi, everybody. I was having my brain work faster than my mouth, and I don't think that's going to help you if you're trying to learn. So we're talking about this as a system of equations with elimination. And we know that we're going to do that because these are both written in standard form there and there. Now, these are not written in such a way that it's going to be easy to start. But if you recall, a while ago, we talked about solving one of these systems of equations with elimination by trying to get the top and the bottom ones to line up so that if I added them together, they would become a 0 or eliminate that variable. Now, I'm going to choose this equation here, and we're only going to go through one of them. But the general idea is to identify the variable that you want to get rid of, and then to try to make those coefficients so that they are opposites of each other. Because the great thing about an equation is, if I multiply both sides of the equation by a number, I'll change all of my coefficients, but the equation is still true. And so when I look at this and say, all right, we got our X's and we have our Y's. I look at the two numbers and see a -2 and a 10. If it's possible to make one of them into the opposite of the other, like I could multiply that -2 by a 5, and that'll make it a -10. That's a pretty reasonable thing to do. And it seems like that would be the one we want to cancel. Check the other one. I got a 2 and I have a 9. Since I know that 2 isn't going to go into the 9, and I can't make that 9 into a 2, I would have to multiply both equations to change them so that these numbers were the same. You can totally do that. And you'll get the same answer when we're done solving. But for me, I try to find one of the variables where we only have to change one equation. So like for this one, I've got 9 and 3. Clearly the 3 I can turn into a 9. I would only have to multiply this top equation. That's sort of what you're trying to identify with this one. So since we know we can make that 2 into a 10, I'm going to multiply this bottom equation by 5 so that this becomes a -10, and now I have opposites. So first, let me rewrite this one. We've got 10x minus 2y equals 44. And then directly below that, I'm going to distribute that 5, and we'll see what that equation looks like when we're done. That will be -10x minus 45y is equal to 50. I am trusting when Michener came up with these problems that we are going to find a simple answer. And if they're not, we'll find out very quickly, I would imagine. So I'm going to add the two of those equations together because these are opposites. 10x plus -10x is going to give me a 0. Now, I just don't write it because if I write it, then I have to do something with it. If I want to remember it there, I have a little 0 there. It goes away. That's totally fine. But we have eliminated the x. -2y plus -45y is -47y. And 44 plus 50 is 94. That actually does divide evenly. Thank you, Michener, for creating a problem that we can solve. Okay, now that I have an equation and I have eliminated one of the variables, I will solve both sides by dividing by that coefficient, -47. This will cancel, and I will get that y is equal to -2. Okay, halfway there. Now all we got to do is plug that y back into one of the other equations, and we can figure out what our x is. And guys, it doesn't matter which equation you choose. You choose the top one, you choose the bottom one. They're all going to give you the same answer. Just because I got crap next to this equation, I'll choose the top one because it's here. So 10x minus 2 parentheses for the y, because I'm going to sub that in, equals 44. And now if I just sub that guy in, put the -2 in there, ready to roll. And I'm living on caffeine as well. So here we go. 10x plus 4 equals 44. Subtract that to the other side, I get 10x is equal to 40. And if I divide, I get that x is equal to 4. So the person that said that privately, x being 4 is exactly right. Now, this is great work for us to show. One of the things they're going to ask you to do is to type in the solution. And this is a solution that you would write in an ordered pair format. 4 is your x, -2 is your y. Because if I did graph both of those, this would be the point where those two lines would intersect. All right, that is elimination. Does anybody have any questions about any of that before I roll on to the next thing we're going to do? Any questions? The silence is deafening. It makes me think that we're good. So I'm going to move on to the next thing, which means I have to switch back to looking at our presentation. Okay, so here's what we're going to do. We went through that. We went through this. Oh, come on. So now we're going to go through looking at the inequalities of one triangle. Okay, so this is where we're going to start to get into the geometry part. Our algebra review is done. Long live algebra. So here's what we're going to try to do as we go. When we're going to be looking at this, I just want to make sure that you recognize when we're talking about an individual triangle, this is essentially saying that we're looking at the lengths of the sides and the sizes of the angles. And this relationship on both sides are going to be the same. If the sides are not equal to each other, the larger angle is opposite the larger side. So C is opposite AB because AB is bigger and C is bigger. A is opposite BC because BC is smaller and A is smaller. So that the relationship between the angle and its opposite side is consistent throughout the triangle. And that's for all three angles, okay? If you have three different angles, The three sides will be different, and they will all be the same relationship as the opposite angles are. So this one basically says if you've got the sides, you can say this about the angles. This one says if you've got the angles, you can say the same thing about the sides. Okay? So that is the inequalities within one triangle and how we kind of get to that. The triangle inequality theorem is the one that we had that where there was that like that animation where we had the two sides where they didn't reach. So it essentially means that the biggest side has to be smaller than the sum of these two sides. And the reason it has to be smaller than that is because if these two don't equal up the sum of the largest side, I think I can do this with annotation. So like if I have got a length of one side that's like that, and then I have one side that goes up to here, this one has to be at the very least bigger than the sum. Hold on. This one plus this one has to be bigger than this because they have to meet. If I'm going to make a triangle, then that means this side plus this side have to be larger than this one, because if they're the same length, well, okay, there's that. And then if this one goes from here to here and they're too small, they're never going to meet to be able to open up and make this space. And if they don't even meet each other here, I don't even have anything more than a line. So just realize the two smaller sides have to be bigger than the third side for me to create a triangle. Y'all good? You got to tell me yes or I don't get to move on. All right, many forms of yes. I appreciate all of you. Okay, so then that means what we're going to have to do next is talk about some example problems. And if I'm remembering correctly, so we can do this. Yep. All right, I've got a slide of this one. So let's see what we can do in my new share. We can do this with the camera. And guys, understand, going back and forth like this always kills my soul. Okay, this is a great way for us to start and a really easy way to write a problem for a test. You name the triangle, then you give two angles and don't say anything else about it. Please listen to me when I say this to you. Draw the damn triangle. If you try to do this in your head, you are screwed, okay? So when you're doing this, it doesn't even matter what it looks like. I just need to make a triangle. See that? I guarantee, this says 99. One of these is already an obtuse angle. I don't care. U, V, W. This is 42. This is 99. Does that look like 99 to you? No, because it's an acute angle and that can't be right. All right, first thing we got to do, help me figure out what my third side might be. What do I got to do? My third angle, not my third side, my third angle. How do I figure out what angle W is?
Add the two angles together and then subtract that addition problem from 180.
So it's 141 with the two of them together. If I subtract from 180, I'm going to get 39 as my other angle. So right now, we have the relationship between all three angles, which means the largest side is going to be opposite the 99, the middle side is going to be opposite the 42, and the smallest side is going to be opposite the 39. Do make sure that you're recognizing the order. I want shortest to longest. Smallest angle is 39. Smallest side is going to be UV. That is less than. Middle angle is 42. Middle angle is opposite that, so it is WV. And the largest angle is 99, so the largest side is opposite that with WU. Okay, now when I have these don't have the lines on the top, so we're talking about their lengths. Totally fine. I can completely keep it this way and we're in good shape. Everybody okay so far? Did that make sense of what we did? I got a yes. If somebody says a no, throw it out there quick. Draw the damn triangle is the right thing to say. Next, example 2. Hey, look, it's another thing where we don't have a triangle drawn. I bet you know what to do. STU. There's not even F in there, and you should put it there in your head. So if we're going to be talking about this one, I am going to make sure that we draw the triangle. Okay. So if we do this, STU. It's triangle stew. TU is 11. US is 17. ST is 18. First off, we know it can be a triangle because of the fact that 18 is smaller than 11 plus 17. Good to go. Which statement about these has to be true? All right, well, let's look. U has to be less than S. Well, U is the biggest one. U ain't going to be less than anything, so no. T is less than S. T is opposite the 17. S is opposite the 11. T is going to be bigger than S. No. Well, guys, process of elimination. We've got this down, right? S is going to be less than U. S is 11. U is off from 18. So this one is absolutely true. And in fact, you could put them in the order that you needed to and then compare it. But it was nice to be able to go through these. Okay. So started with the sides, went to the angles. Y'all good. Got to give me a yes, and then I can move on. Rock. Example 3. I love that it's asking if these can make a triangle. Here's what you do. Anytime that you're going to do this, if you want to see if it can make a triangle, start with the largest side, 6. Okay? 6 has to be less than the sum of the two smaller ones, 2 plus 4. And it's not less than or equal to, because if it's equal to, that means I make one big solid line. It has to be less than those two. Is 6 greater than 6? No, it is not. No. So no triangle. We can't make a triangle if the biggest side is not less than the sum of the two smaller ones. This one, we got 22. Is 22 less than 11 plus 14? Well, these together are 25. 25 is greater than 22. So yes, we can totally make a triangle there. Y'all good? Remember, biggest side less than the sum of the two smaller sides. All righty. Somebody has written in French more than once. No, no triangle. Absolutely right. Example 4. If two sides of a triangle are 16 and 23, what is the range of possible side lengths? I love this. You're absolutely going to get one of these. There's a lot of crap you got to write down here. There are 2 inequalities you got to put together here. First, let us pretend these are our smaller sides. So 16 plus 23 have to be larger than the third side. Okay, so we'll call it X. It's fine, but just make sure that we're seeing this. What is 16 plus 23? Not fast enough. It's 39. Okay, so right now, I know the third side has to be less than 39, okay? Now, it is possible that that third side is not the biggest side. If the third side isn't the biggest side, what has to be the biggest side? 23 does, because that's the bigger of these two. So this is one of my inequality statements. The other one that we have to try then is to say 16 plus our third side has to be greater than 23. And now I can solve this as an inequality. Third side's my variable. So if I subtract 16 from both sides, I can say that that third side has to be greater than 23 minus 16, which I believe is going to be 7. So the third side has to be bigger than 7 for this to work if 23 is the biggest. If the third side is the biggest, it has to be less than 39. So if we want to write this as a compound inequality, we can say that our third side is both greater than 7 and less than 39, because it has to be both. That is our range of values, okay? In centimeters. Okay, centimeters, centimeters. Always look for that crap. Y'all, I'm rushing through this, so I would love it if you put centimeters there. If you don't, I am not going to hold you responsible for not doing that exactly the way that you have. Okay, are you okay with what we just did there for the range of values? Everybody feeling good? Because we got about 9 minutes, which I think is enough. But, you know, I always misjudge time. We need to go back to our slides because I've got to go through what we're supposed to do, not for the examples that we have here. Give me movement. Oh, come on. Example 2, example 3, example 4. Whoop, back up. Inequalities of two triangles. Hinge, y'all. You guys remember the hinge? The Nyam theorem, if I remember right. Basically, it means this. We look for the hinge, which is two sides that are congruent to each other, okay, in a triangle. Then we look at the angle in between those. And if those are not the same size, if one is open more than the other one is, then the side opposite the bigger angle is bigger than the side opposite the smaller angle. So guys, this is the way that it's going to work. And shut up about the tabs. You'll be fine, losers. Here's what we're going to do. When I look at what's happening here, sorry, Madison, I didn't mean to call you a loser. But again, I just have too many things that are up here. And there's too many things in my life. That's all I'm saying. Okay. So when we're talking about the hinge theorem, you're basically just looking for the two congruent sides, look at the angles in between, and then we're going to look at the other side here, okay? Somebody just told me that they have 900 tabs open on their phone, and that makes me uncomfortable, and that doesn't happen very often. Okay, so we're about to go through some examples that go along with the hinge theorem and the converse. Really and truly, when you're looking at stuff, all that matters is you're just trying to figure out how the two things compare, okay? So here's what we're going to do. We're going to start off with this, and I'm going to keep pointing out the things that you are looking for when we do this. By the way, since this is recorded, me calling somebody a loser is now official business on the video. So if you want to play it back for somebody and get me fired, please don't. I need this job. Okay, so if we're looking at this right here, most of the time they're going to attach two triangles with each other. They're going to say, hee, look, reflexive property. That's one of my parts of the hinge. Hey, look, these are my other parts of the hinge. Now, which one of these is bigger? Is 3x minus 2 bigger or is 10 bigger? 3x minus 2 is bigger. So here's what we're going to do. You guys ready? We're going to say that 10 has to be less than 3x minus 2. Everybody good so far? All right, cool. So if we're going to do that, guys, it says the range of values. Just give me the top end value. I don't care about the bottom. So here we go. Plus 2, plus 2. This is 12 is less than 3x. If I divide both sides by 3, that'll cancel. X has got to be greater than 4. There we go. Now, here's the thing. There is a top end to something like this, but the problem that I run into with this is to say, well, okay, we've got a 10, we've got an 8. We know it's got to be bigger. We're not 100% sure what's going to be happening here. So let's just do this. For the sake of argument, we could say a top end. Just give me this one. I didn't talk to you about what that was going to be, and because I didn't share that with you, if you just give me this one, I'm going to say you guys are A-okay. All right. I only need one comparison. We're setting up the inequalities. I will make sure that we have a way of talking about that other side of it when we come back. But for right now, let's just go with this because I don't want to introduce new topics today as we're preparing for this. Okay. Here we go. Everybody ready? Ready. By the way, scrolling through TikTok, not the way to spend your class. Example 2. Hey, look at this, guys. One thing we can do for something like this, if we're looking at the z or the variable being with the smaller side, we can say it has to be greater than 0. So we could do both. So right now, because 24 and 25 are the relationships that are here, 25 is opposite the larger one. So 45 is bigger than 6z minus 3. And if this is smaller where the variable is, I did an x, so let's just pretend. We could say that it has to be bigger than 0. We can do both sides of that. It's just harder to do the top one. Yes, it is a star destroyer. That's right. So now I'm going to add 3, and I'm going to do it in 3 different places, just like that. 0 plus 3 is 3. It's gone here, so there's a 6x there. 45 plus 3 is going to be 48. Then I'm going to divide everything through by 6. Boop, boop, boop. 48 divided by 6 is 8. This cancels out and gives me an x. 3 divided by 6 is the fraction 1/2. We now have a range of values for z that has a small end and a top end. Everybody good? Tell me yes or no, because we got 4 minutes left, which means I'm going to have to keep recording after this is done. Next thing we're going to be talking about, example 3. Guys, we're going backwards and forwards, so you're just going to talk about the relationship between the two. Okay, there's 7 and there's 7. Those are definitely not the same, but it's fine. So right now, these are our hinges here and here. This one is opposite the 5. This one is opposite the 9. So if we're going to be talking about something like that, I would say that this one is smaller. So you would say that the measure of angle PRQ, which is this one, is going to be less than the measure of angle SRP, because that is this one. Make sense? These are the questions that are going to be on the test, just like this. Okay. Oh, what other examples do I have here? Oh, look, we're going to talk about 45, 45, 90s. Okay, I'm just going to kind of keep rolling because I think it's going to be easier. Our relationship for 45, 45, 90 triangles, if we have these two sides that are equal, it's a right angle, which means these angles are the same. These would both be 45. That means that if these are both x, this one right here is going to be x times the square root of 2. That is our relationship when we were talking about a 45, 45, 90. Now, that being said, if this is 8, this is also going to be 8, which means that this guy right here is going to be 8 times the square root of 2. That is super easy because all I got to do is just tack a square root of 2 at the end of the side. It's a little less easy when they give you a problem like this one. So right now, I know that 18 is my hypotenuse. And I know that these are x. So what this would then mean is that we are looking at a variable and square root of 2. So x square root of 2 is going to equal 18. That's ugly, but that's okay. I'm going to write this equation out here that 18 is equal to x times the square root of 2. How would I solve this for x? What would I have to do? You would do something with that 2. Don't square it. I'm solving for x. This is just a number times x. I don't have to think about that. Right now, Ian's got me. Divide by the square root. I don't have to think about this as anything other than just as a number. So if I divide both sides by the square root of 2, this will cancel. And so the answer for x is just 18 over the square root of 2. Now, I will tell you that if you're plugging this into a calculator, it's going to give you an answer that looks different. There's a way of going about doing things where people don't like having square roots on the bottom of a fraction. It was created at a time where we didn't have a lot of calculators, so you couldn't find a value for it. There really isn't a reason not to write the answer this way. I'll talk to you about rationalizing a denominator later, because I just want you to be able to get to the answer, okay? Now, we have 1 minute left, which is fine, but what I want to make sure that we can do is go through more examples if you need them. So I'm going to keep going. In a minute, y'all got to go. And when you do, it's totally fine. But what I'm going to do here is say, when you look at this, just make sure you can keep writing this thing out here and we're good. Now, 30, 60, 90 examples we just talked about yesterday, so I want to make sure that we are clear on what you're expected to do with this one. When we do a 30, 60, 90, what it means we've got to do, this is actually my last slide. If I've got this, the shorter side is opposite the 30, the middle side is opposite the 60, and the longest side is opposite the right angle. So we said that the key for this was the short side. If this is x, then we take that and double it for my hypotenuse. And then for the middle one, it is this length of the side times the square root of 3. Now, for a problem like this one that's simple, they gave us a half. Look at that 1/2 right there. That means that this length of this one is going to be 2 times a half, or 1. All right. That means this y here is going to be that 1/2, because that was this one, times the square root of 3. Now, for this one, I wouldn't keep it this way, because this is like square root of 3 over 1. I would write this as the square root of 3 over 2, so that they could be combined. Okay. Somebody wrote in the thing, so on the hinge problem, we just have to find the bottom range if it's greater than 0, because I haven't taught you that. Yes, that's absolutely correct. Last problem. Okay, we look at this one right here. I want to make sure that we can see what's going to happen. Right now, if I have the hypotenuse, I can work that backwards to find the short side. Because if this is twice this side, that means that this x right here is going to be half of it, which is 3. Once I have my short side, I now have the key to the rest of it. To go to this side, it's going to be 3 times the square root of 3. And guess what, y'all? Mic drop, we're done, and I'm only a minute after because I don't have another one of these. Look at that. It's just notes. Guys, look at that. We win.
For the first time in ever.
Oh, God. Oh, God. That all got recorded, too. I just want you to know I'm excited about that part of it, too. You guys can sing anytime you want. I would love to have you guys sing anytime you want. But for right now, I'm going to stop sharing and say, holy crap, was that a lot of teaching really quickly, but we did do it. You guys have a test waiting for you. You know what you need to do now? That test. Have a wonderful weekend. And it was lovely yelling at all of you guys for all of this time. Bye, y'all. And I know, Mace Windu, that guy might be alive. Bye-bye.